Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Zafrin bin Mat Kusaini and my student ID is 2024427196, and right now I will be presenting about my car inventory system project assignment for CSC508. I have a total of 7 classes and we will go through the array list class first.
First is the array list class. This class is a custom implementation of an array list data structure. The important variables are private object data and private int length max size. The variable data stores all objects inside the array. Length stores the current number of elements. Max size stores the maximum capacity of the array. And this is the default constructor. And next, the constructor is public array list with the parameter of int_k. This constructor initializes the array size based on the value given by the user. And next we have the getMaxSize method, which returns the size of the array list, and the method getNum, which returns the number of elements in the array list, and the method insertFront that insert an element at the front of the array list, and we have the method insertN. This method is used to insert objects at the back of the array list. This method checks whether the array is full before inserting. Next, we have the public void add method that insert an element at a specific index. And now we have the method object getData. This method retrieves data from a specific index. It is used frequently throughout the program when displaying or searching cars. Next, we have the setData method that set the data at a specific location. Now we have a removeAdd method. This method removes an object from a specific index. After deletion, all remaining elements are shifted to the left. And lastly, we have the isFull and isEmpty method. These methods are validation methods used to check whether the array is full or empty. And last but not least, we have the public string print method is to display the list.
Next is the linked list class. This class is used to store booked cars. The important variables are private node head, tail and current. Head points to the first node, tail points to the last node, while current is used during traversal. First thing is we have the default constructor public linked list. And next we have the public boolean isEmpty method to check whether the linked list contains data or not. And we have public string print to print the list. Next we have the public void insertAtFront method to insert data at the front of the linked list. And we have public int size to count the size of the list. And right here we have the public void insertAtBack method is to add a new node at the back of the linked list. This method is used when a car is booked. And right now we have the public object getFirst method. This method returns the first element and starts traversal. Right now we have public object getNext method. This method is to move to the next node during traversal. This method is used to display all cars that has been booked by customer. So right here we have public object getLast method to get the last element in the linked list. And right here we have public object removeFromFront method. This method removes the first node from the linked list. This method is used when rebuilding the linked list after we delete the cars that has been booked by the customers. And lastly, we have this removeFromBack method is to remove from the back of the linked list. This linked list structure allows dynamic storage of booked cars. And this is my array list exception class. It is used to handle errors related to my custom array list. And here is my empty list exception class, which handles errors related to the linked list. It is used when operations are performed on an empty linked list. The next class is public class node. We have the variable object data and node next. So first thing is we have the default constructor public node, and we have public node with the parameter of object data, which creates a node containing data, and we have public node object data and node next, which creates a node together with a link to the next node, and we have public void set data to update the data, public void set next to update the reference to the next node, public object get data to get the data, public node get next to get the next data, and lastly public string to string to print the data. Next is the car class. This class represents a car object. The attributes are private string brand, private string model, private double price, and private INT year. These variables store the car details. The constructor public car is used to create car objects, and the getter methods get brand, get model, get price, and get year are used to access car information. The method toStrings is formats the car information into readable output. This method is automatically used whenever the object is displayed. Finally, the main class of this project is carInventory.java. This class controls the entire system and connects all other classes together. At the beginning, ArrayList stores available cars while LinkList stores booked cars. The system also preloads 10 car objects into the ArrayList using arrayCars.insertN. The menu is displayed using a JOption pin, which creates pop-up dialog boxes for user interaction. The program keeps running using while choice not equals to 10. And this is all the functions that we have in the system. And all the switch case are running using the other classes. Until the user chooses exit, the switch statement handles all menu selections. The method addNewCar allows user to enter and store new car objects into the ArrayList. And the method bookCar transfer a car from ArrayList into LinkList when a car is booked. This demonstrates movement between two different data structures. Next, this remove bookCar method is used to remove a bookCar from the linked list. First, the method checks whether the linked list is empty using isEmpty method. If there are no bookcars, the system displays a message. Next, a temporary linked list called templist is created. The method then traverses the original linked list node by node using getFirst and getNext. For each car object, the system compares the entered brand name using equals ignore case. If the brand matches, the car is skipped, which effectively removes it from the list. All other cars are inserted into the temporary linked list. After traversal, the original linked list is cleared using remove from front. Then all remaining cars from the temporary list are restored back into the original linked list. Next is the method display ArrayList and display linked list. These methods display available and booked cars. Next, the method searchCar. This method is function to search cars by brand name. And the method deleteCar deletes available cars from the ArrayList. And next, the method calculate sum average to calculate the total and average car prices. And lastly, the method findMinMax is to find the cheapest and the most expensive cars available in the system. So finally, exception handling is used to prevent the program from crashing when errors occurs. Now I will demonstrate how the car inventory system works. When the program starts, a menu is displayed using JOption pin. The system already contains 10 preloaded cars stored inside the ArrayList. I will first choose option 1, which is to display available cars. The system displays all available cars currently stored in the ArrayList together with their index. Next, I will choose option 2 to display booked cars. Currently, the linked list is empty because no cars have been booked yet. Now I will test the search function using option 3. I will enter a car brand, for example Toyota. If the car exists, the system displays the car details. Next, I will choose option 5 to add a new car. The system will ask the user to enter brand, model, price, and year. After entering the details, a new car object is created and inserted into the array list using insert n. Now I will display the available cars again. We can see the newly added Hyundai has been successfully stored inside the array list. Next, I will demonstrate the booking feature using option 6. The system first displays all available cars. I will choose a car index to book. For example, I will book index 1, which is Honda City. Then the car object is transferred into the linked list using insert at back. Now, I will display book cars again using option 2. We can now see the book cars stock inside the linked list. Next, I will test the delete feature using option 4. I will enter a car brand to delete. For example, I will delete Ford. Now I will test removing a book car using option 7. I will enter the book car brand, for example Honda. The system traverses the linked list and removes the selected book car. The linked list is then rebuilt without the remove node. Next, I will choose option 8 to calculate sum and average. This is done by traversing the array list and summing all car prices. And now I will choose option 9 to find the cheapest car and the most expensive car. Finally, I will choose option 10 to exit the system. That is all. Thank you.